is our objective on calculating probabilities and the number of ways of selecting and arranging objects. Jaleesa, make sure you're doing this with us right now. A says, determine the number of permutations of all the letters of the word Monday. All right. So like the problems from our book or that we did the other day on the SMART lesson, again, we're choosing all 6 letters and arranging them. Decide what you think a good answer for 6A is. And what did you end up with? 720. And you can get that answer several ways. One of them, again, is to think about all the different ways to arrange those 6 letters. Okay? 6 different letters could go first, and then 5, and then 4, and then 3, and then 2, and then 1. Okay? That's the same as 6 factorial. Or that's the same as the permutation of 6 things, choose 6. Okay? So we have all of those ways to think about that situation. Okay? B says, what is the probability that the permutation begins with an A and ends with a Y? So when I think of this slash notation here, I don't anymore have 6 choices for the first letter. I have 1, and that's A. Right? And I don't have 5 choices left for the end. I just have Y. Right? So I want it to start with A and end with Y. And then once I take A and Y out, how many letters do I have left? 4. And so this would be 4 times 3 times 2 times 1. Again, also known as 4 factorial. Okay. But notice that this answer is a probability. That means it's a fraction. Okay. And it would be 4 factorial over 720. I'm going to go ahead and reduce that fraction. 4 factorial is 24 over 720. Or if we reduce that fraction, 1/30th. Quite honestly, I don't care if you reduce your answer or not. Okay? But again, notice the word probability there. So we went from just how many to a probability. Okay. Another familiar type of question, I hope, number 7. A test includes 8 true-false questions, 5 multiple choice with 3 choices each, and 5 multiple choice with 4 questions each. How many different lists of answers are possible for this test? All right. Again, here comes the question, is it 2 to the 8th or 8 to the 2nd? Or, all right. So try to think through that. This is, again, going to be a really big answer. How are we going to do that with powers or with slashes? Either way. How many different lists of answers did you come up with? Thank you. Again, that comma calculator thing would be so nice. Okay. When I think about this problem, I think in a couple of different ways. Okay. One of the ways I think about this problem is, again, with this slash notation. Because, again, I often get the question, I never remember if it's 2 to the 8th or 8 to the 2nd. Well, our number of options for true and false are true or false, true or false, true or false, all right? And that would be 2 to the 8th, And then we have 5 multiple choice questions with 3 options each, ABC, 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 or whatever. Again, and there are 5 of those, so that's 3 to the 5th. Notice I'm multiplying all of these because we're answering all of these. And then 5 more multiple choice with 4 options each. 4 times 4 times 4, or 4 to the 5th. I just did a dot, dot, dots here because if it's 20, it's not real reasonable to write all of those out. Okay? And when I multiply all those together, that's how many different possible lists of answers there are. Okay. Number 8 says a restaurant offers 6 salads, 3 soups, 5 entrees, 4 desserts, and 6 beverages. If you want to order one item or an item from each of the 5 categories, how many different meals are possible? Please decide what you think is correct for number 8. Have any ideas? 2,160. We're going to take our salad options, multiply them by our soup options, multiply them by our entree options, times our desserts, times our beverage options, and we end up with 2,160 different meals. You could eat at that restaurant a long time without having the exact same meal. And the last one, I think the most challenging question in this section. It says a school has 600 male students and 400 female students. 3 students are waiting at the bus stop for a ride to school. What is the probability that all 3 are of the same gender? Okay, so the same gender means that we could have, and I'm going to go ahead and show this down here, an all-male bus stop waiting group, all right, or an all-female group. Now again, look at that word probability, okay? So with that word probability, we end up with an answer between 0 and 1, all right? It's not the number of ways, but it's what the probability is. So we're going to have 3 things right here for our 3 male group, and then 3 things right here for our 3 female group. But again, I raised my blanks a little bit because it's going to be a probability, not just a number, okay? How many students are there total? 1,000. How many of them are male? 600. So the probability that one of these gentlemen is waiting for the bus stop would be 600 out of 1,000. But then once we have a man or a boy at the bus stop, then there's one less to pick from, right? So the probability for the second time would be 599 over 999. All right, because if somebody's already standing there, there's one less person to pick from. Okay, what do you think that third fraction is? 598 over 998. Okay. Now for the all-female group, again, we're putting everybody back in the pile, so we have all 1,000 people again. Okay. How many of them are female? 400. Again, if a female is standing at the bus stop, then we only have 399 available females out of 999 people. And then 398 out of 998. Okay. Now, one more word here is that the group could be all male or all female. Now here I've got a male and a male and a male. When you hear the word and in probability, it most often means multiply. Again, I've got a male and another male at the bus stop. Sorry, and means multiply. When you hear the word or, that means add. So here I've got a male group or a female group, so I do add those together. All right, figure out what the correct answer to number 9 is, please.